In a universe that appears still and silent, there are invisible motions that our eyes can't perceive. The empty space we often imagine is, in fact, a realm where energy never truly rests. This may sound like science fiction, but it forms the basis of one of the strangest physical discoveries of the 21st century, quantum energy teleportation. Unlike the traditional idea of energy transfer, which requires a physical medium, wires, or waves, QET allows energy to appear at a distant point simply by harnessing quantum entanglement in information. No particles are sent, no photons or electrons, just the right measurements, and the energy moves. Let's explore this world and discover how the universe may operate very differently than we ever imagined. According to quantum mechanics, even in the most idealized conditions, where no physical particles exist, there is still energy. Physicists refer to this as vacuum energy. Heisenberg's uncertainty principle tells us it's impossible to simultaneously know a particle's position and momentum with absolute precision. Therefore, even in its most basic state, the so-called zero-point energy, a field still fluctuates. These are known as quantum vacuum fluctuations. Imagine you're staring at the surface of a still lake. It looks calm, but under a microscope, you'd see countless tiny ripples rising and falling randomly. That's how quantum empty space behaves. But there's something even stranger. Fluctuations at one point in space can be linked to those at another point far away. This linkage is called quantum entanglement. When two particles are entangled, measuring one immediately affects the state of the other, regardless of distance. While entanglement can't transmit usable information faster than light, it suggests that our universe is fundamentally interconnected in a way classical physics cannot explain. And this principle lies at the heart of QET. In 2008, Professor Masahiro Hotta from Tohoku University in Japan published a groundbreaking paper. He demonstrated that if one measures a section of a quantum field and transmits the measurement result to a distant location, energy can be extracted there. It may sound like teleportation, but it's actually a sophisticated manipulation of information and mathematics. Hotta used the classic theoretical duo Alice and Bob in his protocol. Alice stands at point A and Bob at point B. These locations aren't physically linked, yet they share an entangled quantum field. Alice performs a complex measurement on her region of the field, disturbing the local energy structure. She then sends her result to Bob via classical communication. With this data, Bob can perform a targeted measurement on his end and extract energy from his vacuum region. No particle is transferred, no photons, no electrons, no physical motion. Yet energy appears at Bob's location, seemingly teleported from Alice. In other words, this is a method of using information and quantum entanglement to extract energy from the vacuum itself. In 2022, researchers at the Institute for Quantum Computing, IQC in Canada, tested Hotta's idea. They used a molecule called transcrotonic acid, with carbon atoms acting as qubits. Using nuclear magnetic resonance and an NMR, they created entangled qubit pairs. One qubit was disturbed via measurement, and energy appeared in its partner, even though no physical energy was sent. In 2023, another team at IBM reproduced the experiment using superconducting quantum computers. The result? Identical. In fact, in some scenarios, the energy transfer occurred faster than energy would normally propagate through material in that system. Though the amount of energy moved is tiny, measured in nanojoules, this marked the first time humans have controlled energy to appear from empty space. QET is not just a technical achievement, it's a philosophical shift in how we understand the universe. If energy can appear in a location through informational setup, then what are the true boundaries of physics? Could we build devices that harvest vacuum energy to power nanoscopic machines? Could we even bend space-time to create wormholes, warp drives, your time machine? Interestingly, QET enables the generation of negative energy density. According to Einstein's general relativity, such exotic energy is necessary to construct stable wormholes or warp bubbles. Though real-world applications are still years away, many scientists believe that in the coming decades, QET will play a role in quantum computing, wireless nanoscale energy transfer, and even simulations of cosmic phenomena. The universe is not just space and matter. It is a vast, intricate network of information, where energy and reality itself are shaped by observation and measurement. Quantum energy teleportation is proof that with the right knowledge, we can achieve what once seemed impossible, transferring energy across space without moving anything at all. The future is still distant, but today, with each small discovery, science continues to peel back the veil of reality, bringing humanity closer to the ultimate edge of existence.